And now she's educating her peers and her colleagues. And do you know who's suffering here? And this is why I'm a bit frustrated. The patient is suffering, because it's very hard to do PhDs and publish papers the way we do, when a typical paper, when done right, with IRB and study protocol and everything that's, patient-centered. And when we demonstrate something that's effective, something that works, it's, already your industry is not doing enough in this space. America is wonderful. You go at it, you try new technologies, but we're only at the tip of the iceberg, whereby eye care and optometry is understanding and embracing and has the confidence to make decisions with supplements that help their patient and with measurement technologies that can help their patient.
Hello and welcome to the Crystal Podcast on iCode Media. Today, I wanted to have a discussion with Dr. John Nolan, and I want to talk about carotenoids. I put this out this last week, and I watched a webinar from a couple of weeks ago that brought up a lot of points with carotenoid measurements, with carotenoids specifically in terms of where they're absorbed and how we can know what MPOD levels are for our patients. And it made me kind of reevaluate my understanding of the literature. And it forced me to kind of go back and say, is what I'm thinking on this right? And so I reached out to one of the panel members on that previous webinar. I'm not going to mention who it is today. I'm hoping that they'll come on the podcast at some point in the future and have a conversation about it. But it did stimulate my questions, and so they declined. They're not coming on. I also asked Dr. John Nolan to come on because I know John, and we've got a relationship over the years. And so I wanted to pick his brain about some of the things that I learned from that webinar, as far as how it was counter to some of the things that I had previously learned. So really, John, thanks for coming on. Appreciate it. Thanks for taking the time to do this.
Pleasure. Always pleasure to join you, Chris.
The other thing that I wanted to kind of state is, clearly, if you've listened to the podcast before, you know that we have some sponsors. We have Cooper Vision, we have Essilor, we've got MacuHealth, and those are sponsors of the podcast. And I want to kind of draw a line, because we're not going to try to use I'm going to try not to use any specific supplement names in this episode. The other thing I'm going to try not to do, obviously, I have biases. I'm trying to mitigate those biases as much as possible by disclosing them. The second thing is that I think it's really important that my approach to what we do for our patients in my practice is that when things are clinically equivalent, then I tend to try to use companies that I like their background, or I like the people that work for the company, or maybe we get better deals on that. But when things aren't clinically equivalent, then I look at it as I don't have a choice of which company to use. So by saying that, I'm saying, okay, well, if all the evidence of what we evaluate in the supplements that we use is just that, well, this supplement is good as that supplement, or we can interchange things, then it comes down to just like, which brand do you like better? But I feel like my understanding in the past was that, the brand that I liked better also was clinically better. But this webinar, John, made me question that. And so that's really what I want to talk about. And the first topic I want to get into is measuring and correlating carotenoid levels. So in this webinar, one of the things I learned was that, a lot of us think about, okay, well, if I want to know macular pigment optical density, why would I use a device that doesn't measure macular pigment optical density? It would measure something like skin carotenoid levels. And so I think I had a discussion with Jim Stringham about this about 18 months ago, but I kind of forgot a little bit of the piecing together of why we can trust skin carotenoid levels. So the first thing is, John, why don't I use MPOD levels? If I want to know what's going on in the eye, it's intuitive for me to look at the end organ, the eye, to look at macular pigment optical densities. So why don't I just use that as the device that I use to measure a patient's macular pigments?
So the holy grail is to measure the target tissue. So measuring macular pigment is where we would all like to go to. That's what we do here in the research world, where we have time to dilate patients' eyes, where we can get a full image of the macular pigment, and we can understand the full pigment even beyond measuring at one point. The reason why you wouldn't, as a clinician in the clinic setting, is that there is no clinic friendly or reliable device out there that has been tested that will allow an eye doctor to get a number that correlates with the absolute measurements of macular pigment. And the reasons being is, I've used flicker, so there's different ways you can measure macular pigment. You can chop up the eye when you don't want to do that to your patients, right? That's not a possibility. And if you were to do that, you could do HPLC and you could see exactly what's there. And we do that in when we have postmortem eyes and so on. And that measurement is absolutely exact. The other way you can do is that you can image it. And imaging the eye is, there's assumptions around any measurement. So even imaging the eye has assumptions that you must get right and control for. But
Can you tell me what those assumptions are? I mean, very briefly. Sorry, this is where my mind goes. What are those assumptions, and why can't we just build a device that I can use to measure that pigment?
Because it depends on the technique. So if we're doing an imaging test, like autofluorescence, for example, you have to make an assumption that the lipofuscin is uniform across the entire macula, which we know it's not. So when you do that, you have to be able to adjust and control and optimize for that. And that's why with autofluorescence we use two different wavelengths. So we use blue and we use green. And because macular pigment is yellow, it absorbs blue light. And therefore, if you essentially excite the lipofuscin, which gives off an emission with a blue light, you'll have this suppressed area that is directly correlated to the macular pigments, because essentially the pigments are filtering the light. So it gets in the way of the blue light getting to the lipofuscin, and there we have this kind of darker suppressed area. But importantly, you have to repeat that essentially with green, which is not interfered with by the macular pigments. And that is one of the ways that we can, that's why we call it dual wavelength. We're using two wavelengths. We can subtract what's unique about the human being, everything, which is kind of complicated inside the eye, that makes the measurement difficult. And that's in a perfect world with imaging techniques, typically techniques that are, I use Heidelberg system, it's an autofluorescence system, it's a Rolls-Royce system, and we optimize that. And we spent over a decade optimizing the software and the protocol to get us to do that.
So let me. So again, why don't the cost of that? So let's say, all right, John, fair enough, fair point. You've optimized that. What's my cost as a clinic, and what's the time it takes to measure that?
Well, it's not available for clinics. So it was created for a research environment. So it's not like even if you have a Spectralis, which is the system I use right now, that software is not available for clinical application. It is for research right now today, for research purposes only. So it's not an option. So the Rolls-Royce measuring of macular pigment, unfortunately, today is not available. And that's why, when I've been talking to eye doctors all over the world about the importance of macular pigment, we would all like to be able to measure macular pigment. The other way, of course, is to use flicker photometry, which again, Chris, in the context of the research setting, I spent many years, myself and colleague Randy Hammond, Bill Wooten, people that have spent their life working on this area, would have developed protocols for research purposes. And with flicker, the assumptions are far greater, and the risk of getting it wrong is far higher. And at the very least, and at the very best, if you like, with flicker photometry, it takes a long time to do correctly. Because again, back to assumptions. We have to be able to adjust for what's going on in the lens. We have to be able to see the difference between a 50-year-old person and a 20-year-old person if we're measuring macular pigment. And the only way to do that accurately and with reliability is to do two wavelengths again. So similar to imaging, with flicker, you have a blue and a green, but you also need to have a fovea, which is in the center, as you know, and a parafovea, which is in the periphery. So in other words, you have to use the patient as his or her own control when measuring macular pigment with flicker in order to get a measurement that is in some way related to their target tissue. But even with that, the chance of getting this wrong in the clinic setting where light environments are different, where the devices are not optimized, where you do not customize, we've seen it fail time and time again. And the flicker devices...
When you say, sorry John, but when you say it fails, we see patients that take visual field tests that aren't reliable. So I can make decisions on a visual field when I know reliability scores and say, I'm going to throw this out or I'm going to throw that out. Can't we do the same thing with this test in the clinic?
No, well, you can if you use the right system and if you spend time using the system, but that's certainly not a 5-minute test or a 2-minute test as some of these flicker tests are promoted in the clinic setting. And most importantly, if you're to do that, one would have to validate such a system. You would have to compare your quick, crude screening macular pigment system against absolute standards. So how do we do that? How do we validate a system? We compare it to lutein in the blood or zeaxanthin in the blood. And again, that's an experiment that's part of the validation. Or you compare it to a system that has been used, that has its own validation. So like the imaging system that we use. So if you, Chris, developed a new technology today that you said, I can measure macular pigment using flicker, I'd say to you, great, let's see how well that works. Let's compare that to absolute measurements in the blood. Let's compare that to systems that have already been validated. Let's see if we change nutrition, lifestyle, or supplementation, that measurement changes appropriately with the known biochemical markers like in blood. So this is all part of validation, and that takes time.
Well, yeah, of course it does, and I think I think it would be kind of the ideal for what we could do. But what I'm hearing from you is there's this variability that we don't know exactly how to know if the test is good or the test isn't good, or you're saying sometimes it's just such a quick answer that you're trying to get information that's yes, no, essentially, or high levels, low levels, whatever those numbers are.
Yeah.
And it's variable, and it's dependent on the patient and depending on the patient's cooperation. Is there a way for me to know, like clinically, if I use this, if I can rely on that data or I can't rely on that data on that one specific instance?
Well, you would have to see if any said system had been validated, had been used in science. There's no quick, just because you get a number. I've heard this sometimes from doctors saying, oh, I don't care, I just need to get a number. I can work with a number. And I'm like, no, that number needs to be unique and relevant to your patient, because if you want to make a recommendation to your patient about lifestyle or about supplements that you choose to use, you want to be sure that that patient is responding to any said supplement. So there's a lot in the background to getting this right, and there's only one worse measure than not measuring, and that's measuring something that's not giving you a value that your patient deserves honesty here.
Have you seen any of the, I mean, so obviously these devices are clinically available. Is there one that has been validated? You know, on the webinar, I learned that there was, and actually I'm going to cite it here because there was a study that they cited that said macular carotenoid supplementation improves performance, sleep quality, and adverse physical symptoms. And the actually no, that's I'll get to that one. The other one that I was looking at was the study that was cited was referenced that this technology that was available for clinical use was studied in one of Jim Stringham's papers, but then there was a reference that was kind of a little slip, and then it said, well, the base technology was studied in Jim Stringham's. So my question is there anything clinically available, commercially available for me to use in my practice? Is there studies that are actually directly used that you're aware of that use those clinically available devices to measure MPOD in my office that show that it's reliable, and valid and repeatable. That isn't referencing a different study on a different type of maybe lab-based flicker technology.
So, yeah, I mean, there's a couple of assumptions there in your question, so I'm trying to follow. I'm trying to.
Okay, I'm sorry. You can pick apart those assumptions.
Yeah.
I'm just trying to understand this clinically.
Yeah, no, okay. Let's just say you were to create the flicker system, so the flicker system that we use that is very effective is the densitometer, which was developed by Professor Billy Wotton out of Brown University, and his systems are, not very pretty for the clinic. There's a lot you need to do to optimize the patient. You do fovea and parafoveal testing. My understanding is there is no such clinic device being used in optometry industry in the world at the moment in that situation. And the reason being is that when you do it right with flicker, it takes a hell of a lot of time to do it right. And even if you do it right with flicker and you've a really good technician and you optimize the whole setting, you're measuring 1 point on the whole curve of the macular pigment. So you're missing, when we image, we see the full mountain of that pigment. We see people who have dips. We see people who have broad profiles. If you're measuring at 1 point of the mountain, you're highly limited. My concern, though, and let's just get to the point here, is that, and my concern is for the eye doctor that's been misled here, to be told that this is the only way to do it. And we'll come back to your question on skin in a minute because I think it's important. That's misinforming. I didn't see, I'm familiar with the presentation you were on. I didn't see the whole lot of it. But I did see on that presentation an eye doctor who asked a question to the presenter and said, tell me what I need to know about this. And when someone is misinforming another eye doctor who has the responsibility to inform other eye doctors and most importantly their patients, and when you don't have the knowledge, or if you're not knowledgeable on the topic, that's not great if you're presenting as an opinion leader. Some of the basic fundamental points about macular pigment were just totally misrepresented on that webinar that you're referring to. So that's not right. If you don't have enough information to do your job, that's a bad thing. Or worse, if you do know and you're just not being honest and not providing correct information. And to your point, there's three types of science. There's science that doesn't exist because there's no science to it. There's science that some organizations and industries make reference to that other people did. You can look at supplements even there. You can look at how many million ARIDS formulations have we out there. They're drawing value from a study that was in that time the ARID study, and they said, okay, lutein is good or zeaxanthin is good, and let's do that. And then there's actually science that organizations create themselves with their own technology and deliver that exact technology to the doctor and most importantly to their patients. And that's where we need to be. That's where you as a doctor, I believe, and your colleagues need to be. Your patients deserve the right information and not a misrepresentation.
Well, and I think that's the challenge, John. And that's one of the things I wanted to have you on. And I think I think we've hit this point enough. I want to go to a couple other topics because I want to be respectful of the listeners. One is I learned from the webinar that there is only an 8% correlation between skin carotenoids and MPOD level, even down to the level of if I go outside and I'm suntanning at the lake. And then I come back in and I see an eye doctor that's measuring skin carotenoids. Those skin carotenoids are going to be depleted. Now, to your point, you say, well, we have to be able to rely on the data we're getting to make good decisions because bad data gives us bad decisions clinically. All right, so does that happen? And if it happens, how do I protect against that clinically?
I'm sorry for laughing, but that's just made up. That's not the case. So that you go out in the sun.
Where did it come from? It came from no place? That webinar said that piece of information, it came from nowhere.
Did they cite a study that showed an 8%?
I did not see that. No, I didn't see that.
Okay, so there you go. So if something is said, I think we have it and by the way,
correct. We absolutely do.
I'm a scientist.
And I'll put this out here right now. If that is not if that's not true, and there's no citation for it, I've said this already. I've reached out to the person that said it through LinkedIn. I have invited them on. I will do this again. Please come on. I'll have an open conversation about this. I want to see the data. But that's the important part, I think, about this, John. So please, go ahead. So, all right, so what is the correlation then? If it's not 8%, John, what's the correlation between MPOD levels and carotenoid levels in the skin?
So typically when you look at the relationship between carotenoids in the skin and macular pigment, there's what we call a Pearson correlation of about 0.6. 100% agreement is a Pearson correlation of 1. So you're looking at you square that. So you're looking at about 30 to 40% correlation, which is wonderful. Because if you think of the context of what I would like to see happen in clinic, that a doctor can do a test on their patient that gives them a measure that is unique and accurate to that patient. And if the doctor is to support that patient to make a lifestyle change or a supplement change, that they can see if that intervention is working. Now we have a system in terms of measuring carotenoids in the skin. I mean, I did see some of the presentation, and I think the same presenter said that there was 40 carotenoids in the skin.
I think it was 45. That was actually another question I had for you. So if you want to go there, 45 carotenoids. So given that there are 45 carotenoids present in the skin.
There's not. Again, how can someone be presenting in an environment where the duty of care...
Did you say there's not? There's not 45 carotenoids in the skin?
No, there is not.
How many are there?
There's maximum, depending on diet, 12 carotenoids in the skin. And we know this from skin that has been analyzed on
Will you send me data? Will you send me the studies on that?
100%.
And I'll put them in the links. Okay.
There are numerous studies, Chris, on that.
Okay, thanks. Keep going. So 12, not 45. So 12 carotenoids in the skin.
There's not 45. And most importantly, the levels, and there's two ways you can measure carotenoids in the skin. One is you can use a Raman system, which is basically you put your whole hand on it and it excites Raman. It creates Raman scatters that are unique to the carotenoids. And that's
Raman scatters?
Yeah, so we can measure it's like a unique fingerprint of the carotenoids, and they get excited in a particular way, and you can capture the quantum, you can capture the energy. And this has been validated very well. And again, by the way, I have no involvement or commercial connection to any of these measurement companies. I'm just happy that they exist because they do give doctors a tool to use to measure carotenoids in the clinic setting in a very valid way, and in a way that does correlate with the target tissue. And to the point, there are only the system we use is the life meter, which basically measures the absorption. It's a spectrophotometer. It's a scientific device. And what happens is, if let's just say, Chris, I take you and you worried about your carotenoid profile or your vision related to carotenoids, and we want to do something. If I take you in now today, I can measure your carotenoids in the skin, basically on the spectrophotometer, which is the life meter. I'll get a score for you that puts you low, medium, high, or whatever the case may be. And if we positively change what we do with you, with, say, carotenoid intervention and lifestyle optimization, I can see and detect and measure the change of that. And now
is there so thanks. Sorry to keep interrupting, but is there a variation between the amount of carotenoids I might measure in my palm or my thumb or my forefinger? I mean, that was another claim that I learned from this webinar, is that there's lots of variability depending on where I measure it. So that obviously means I got to measure the same finger every time, or could it be that even if I get a little off from where the finger is at, it's going to change?
You are measuring the same finger every time. It's part of the protocol, and the variability is minimal to the point that we don't see it. The reproducibility on this technology was developed by Werner Gellerman, a colleague of Paul Bernstein, and Paul himself is a world leader in macular carotenoids, has published extensively on carotenoids in the skin and how this technology can and should be used both for research. But the difference now is that this is a technology that can go into your practice and that will give you a number that's unique to your patient. And we know if we get things right, that number will change in the direction relevant to what's going on.
Okay, so but I want to get in on this point, because you said, well, we're with the skin carotenoid levels, we can correlate that to retinal carotenoid levels with you said some kind of number of 0.6. I can't remember the labeling of it.
Yeah.
And then you squared that and you said that's 40%, right? It gives us
40%, depending on the study you look at. And there's many of them. Yeah.
And so
data from our own lab. Yeah.
But your point is that it's reproducible, that even though that your number is not directly correlated like 90 or 100% of your MPOD, it's reproducible, and it's and you can make decisions if that number is low. You can make decisions that you're following over time. That's what you're saying?
That's what I'm saying, and I'm also saying that it's not just an idea in my head. It's been validated in a clinical study. And
you'll share that with me as well.
Yeah, all our studies, the Remind study, the COAST study, we measure now as standard as part of our protocol skin carotenoids.
Okay,
and when
I'll
we
share
use
those.
Super duper imaging technology, which is not clinically available, and the responders go in the absolute same direction. So what we're able to do in skin is 100% indicative, representative of what's happening at the target tissue. So it's a wonderful development for our field. So, any educator or presenter that tries to take that information and knowledge from the eye doctor is doing a disservice. And actually, I think they need to apologize. Particularly to the other doctor that was on that show, Chris. I felt sorry for that. I can't remember the lady's name.
Yeah, I don't want to mention anybody's names.
She was asking questions, and she was misled. She was misled within that seminar, and published papers the way we do when a typical paper, when done right with IRB and study protocol and everything that's patient-centered, and when we demonstrate something that's effective, something that works. It's, already your industry is not doing enough in this space. America is wonderful. You go at it, you try new technologies, but we're only at the tip of the iceberg, whereby eye care and optometry is understanding and embracing and has the confidence to make decisions with supplements that help their patient and with measurement technologies that can help their patient. When we have misdirection, it's either that they really don't know what they're talking about, or they do and they're being dishonest. And I'm calling that out.
I think, and that's ultimately, John, that's what I want to kind of keep digging into, because I have more questions again, and now I've got, I think we're on to 2 or 3 things that I caught that changed my understanding, but you're saying those things aren't accurate. So I want to dive again into it. So you're saying, all right, if there are 12 carotenoids in the skin, there was also something else that I learned that was talking about, when we talk about like cognitive ability, or even just like some of the studies that Jim Stringham has done on even just comfort. I think that was the one I was going to refer to as adverse physical symptoms. So less adverse physical symptoms. And there was some discussion about when we talk about carotenoids in the brain, like 75% of them are lutein and zeaxanthin. Is that true?
No. And you look at Liz Johnson's studies. I mean, so everything you've said to me that was presented at this event is scientific, and it's not my opinion, and it's not my emotion.
Okay. So then what's the numbers? What carotenoids are in the brain? When we have that finding, what are we increasing in the brain, and which of those carotenoids are important?
Well, like if you take a supplement with lutein, zeaxanthin, or mesozeaxanthin, your skin accumulates those specific carotenoids. And I've seen in animal studies that while if you take an unsupplemented human with carotenoids, they'll have very low, if any, zeaxanthin. Lutein is more common. Beta-cryptoxanthin is more common. You see these other carotenoids there. But, when you supplement, by definition, you're changing what happens, and you're changing the target tissues. So when you supplement with lutein and zeaxanthin and mesozeaxanthin, or whatever, maybe different carotenoids, they will find their way to target tissues, and we've seen this in the animal models. So but it's, again, because I don't have the particular stat that was presented at that webinar in front of me, but it's just scientifically inaccurate, and it needs to be corrected. Because
all right, fair enough. And that's one of the things. That's why I'm asking you specifically about these things. So then that kind of leads me to the next question about, the macula. Again, my understanding, John, and maybe I'm misunderstanding this, is that our macula can produce mesozeaxanthine. So there are three main carotenoids in the macular pigment. And obviously they are lutein, zeaxanthine, mesozeaxanthine. But our macula will produce mesozeaxanthine from lutein primarily. It will actually change that when it needs it. But I learned from this webinar that mesozeaxanthine is nowhere else in the body. It's not produced anyplace else in the body other than the macula, and it's only produced on demand. So there's no reason to provide that supplement to bolster macular mesozeaxanthine, because it's not needed as long as you have enough. If I'm understanding this correctly, and I could be misunderstanding this, and again I'm frustrated because I do feel like when I look at those webinars, I feel like people are doing things in good faith. So I'm still going to take the approach. I think you're upset, clearly. I'm still basically saying, like, look, these presenters were presenting in good faith. Maybe there's just a misunderstanding of the evidence, and that's why I wanted to have some discussion on here with not just me, but the other presenter and you. But I'll assume it's good faith.
Did the
why
come?
Why? But why, John? So is it true that mesozeaxanthine doesn't exist anyplace else in the body, and by supplementing, you might force those mesozeaxanthine into target tissues that isn't used to it? And do we even need to supplement? Why do we need to supplement with mesozeaxanthine when we can create it from lutein?
Well, the first thing you said is really important, and that's the macula chooses to concentrate mesozeaxanthine as the primary central carotenoid. And the same presenter ignores the fact that the body does that it's an important thing. They present it as zeaxanthin incorrectly. It is mesozeaxanthin that is the most concentrated carotenoid centrally. We know this from studies where we analyze retinas and maculas. We've seen this has been going back to Bone and Landrum's work a long time ago. So for some reason, the body thinks mesozeaxanthin is crucially important. To your point, well, do we need to supplement at all? Well, I would throw that question out to the entire supplement industry, including the lutein people and the zeaxanthin people and everyone else in between. When you supplement, you do something that's not normally happening. It's why it's a supplement. And we believe that it's the right thing to do because target tissues and cells benefit from enriching these particular carotenoids. What's wonderful about the science of our time, and the science that I was involved in with CREST, which was quite disruptive, to say, wow, let's just fix the problem of deficiencies in mesozeaxanthin. Because to your point, we've done thousands and thousands of intervention programs with people with lutein, and they leave the experiment with central dips. We don't fix their problem, a problem being they have a lack of mesozeaxanthin. So those individuals are not able to use the lutein that's normally coming in their body or from the supplement to make mesozeaxanthin. It is.
Could that just be? Sorry, John. Could that just be a problem with their biochemical conversion from lutein to mesozeaxanthin?
Absolutely, what we think.
Could there be a more precise way to know who's going to have that biochemical deficiency?
I think there's work underway at the moment. Paul Bernstein is doing a lot of work with particular enzymes and so on to see what actually is going on there. But we do know when you provide mesozeaxanthin that those same individuals that have that deficiency, if you want to call it, respond remarkably well. And this macular pigment is made up of 3 carotenoids, not 2 carotenoids. And study after study has shown, whether it's in the healthy population or people with macular degeneration or patients with Alzheimer's disease, when we provide the 3 parts of the macular pigment jigsaw, the results are far superior. So we shouldn't ignore the fact that the body takes the trouble to accumulate this particular carotenoid. You know, these carotenoids are very similar. And if you've seen my lecture, I call them brothers and sisters because they're similar.
I have not. I haven't seen it.
But they're also uniquely different because mesozeaxanthin is the much more powerful antioxidant. Paul Bernstein has shown this in his in vitro studies. So if you get a glass like I have here, and if you were to fill that with mesozeaxanthin and you have to get another glass and fill it with lutein, and another glass and fill it with zeaxanthin, and measure its antioxidant benefits, its antioxidant potential. Mesozeaxanthin wins. But here's the thing, if you get one more glass, Chris, and mix them at the same total amount, and mix them, now we have a winner. The antioxidant potential of what the combination of the carotenoids can do is far superior to just providing lutein or just providing zeaxanthin. And that was a discovery, and that's the discovery that shouldn't be hidden from the eye care community, ultimately from the patients that benefit from this and have benefited from this. I did a count the other day, Chris. We did an audit at our centre here. I've now measured carotenoids in over 46,000 people. So 20 years of work measuring carotenoids, trying to figure out how we should go about this and what we should do. And look, you kicked off this discussion by drawing a line. Let me draw a line here just for clarity, because I think you have to be fair to me too.
Yeah, please.
To be able to do that. I work for a university. I might be known as the Macu Health guy, and I'm really proud of that. And you know why? Because the science that we have done at this university by, 30 people, their PhDs, their life, different disciplines, the technology that has been created at this university, I don't own it. Okay, that is licensed and protected and used carefully. And that is a measure of success, because it's so valuable that intellectual property gets to be protected. And it's the science, as I say, starts with how it's formulated. It's not just copying an idea like a lot of organizations do. Fair enough, they have to have a go. But if you have an organization that is able to, live from the beginning to the end in terms of the quality piece, that's why I said there's 3 types of science. There's science that people just don't care about, they're going to sell anything. There's science that people say, okay, study X has shown something important, I'm going to get access to maybe a compound that can do the same, we'll copy it. And then there's science that lives and has been created and has been utilized and made available. And that's the science I want your doctors to have access to. But there's one thing,
that's what I want to have access to. Yeah.
We should be honest though, Chris. We should be honest. And
I agree. I agree.
I'm disappointed the doctor didn't come on to have this conversation, because it's just disrespectful.
Well, listen, I'm gonna continue to reach out, and I hope that he will. And I'm optimistic. Again, I think our profession generally is a good profession, and people are good people. So I give those people the benefit of the doubt that maybe there's just a misunderstanding of data, and we can kind of air that data. So I'll continue to reach out and try to bring them on. I have 2 more questions. Actually, 2 more questions. One is, let's not assume. Is there any potential risk of supplementing with mesozeaxanthin that we get benefit in the eye because where it goes, but there's a potential detriment to other end organs of mesozeaxanthin? Any risk that we know of?
No, I'm glad you've asked that question. And there's different ways to assess risk. Okay, so you have to follow people from a long period of time. I now have 10-year data of supplementing with the 3 carotenoids, including mesozeaxanthin. The effects that we see with lutein remain. They're just added to. They're better. When we use lutein-only interventions, we're seeing 20% non-response. There were some false claims that made by the same presenter that, when you supplement with mesozeaxanthin, you're not going to respond to lutein or zeaxanthin, or I forget which one he said exactly. But
I don't recall that.
We've optimized. It wasn't on this one. It's been on other seminars.
Okay.
And that's why we do dose response. So you start at low amounts of carotenoids, and you go. I supplemented up to 20 milligrams of meso at one point, and it wasn't that I saw a problem of doing that. I just saw no extra benefit to what we were seeing with the 10 milligrams of mesozeaxanthin. And remember as well, how these are sourced, Chris. You talk about risk. I'm glad you mentioned the word risk, and this is where certification of the formula is really, really important to me. Okay,
yep, and that's my next topic. So keep going.
Will I keep going? Because when you look at it, how do we get lutein? We get lutein and mesozeaxanthin from the marigold flower, typically from Mexico or wherever, different parts of the world. But our formulations all come from Mexico, from an organization called Industrial Organica. So they are the provider of the formula that is used in our studies, which has been made available via macular. Okay? Now, the process by which they take the carotenoids out of the plant, the marigold petals, these are sempasuchas, is optimized in a way that you can increase the mesozeaxanthin. So you get lutein and mesozeaxanthin. And you get a small amount of zeaxanthin because it's just there in small amounts. So we do know that lutein can be converted into mesozeaxanthin, similar to what we see in the eye. But remember what I'm saying here. You're getting lutein quite easily from the plant. You're getting meso quite easily, as we call this isomerization. That's where the only difference between lutein and mesozeaxanthin is the location of a double bond in this kind of, it's like an end chain. It's like a wheel of a bicycle, if you like, and one of the spokes of the bicycle moves one different location, and the molecule is different, and it makes it a more powerful antioxidant. And I believe the reason why we have meso in the eye is because of that enhanced antioxidant and optical benefits. But where does zeaxanthin come from? And this whole thing said about, we need to have zeaxanthin, and I think it was said on the same presentation, mesozeaxanthin is because of the body's deficiency in zeaxanthin. Again, there are no citations or papers to back that up. So where did they get it? You have to extract it, and if you extract it maybe from paprika, for example, I've looked at the chromatography, which is when we look at, if you like, the DNA of what's in there, and there's a hell of a lot of other things in that zeaxanthin formula than just what's on the label claim. It's beta-carotene. Now, maybe that's a good thing. But does the patient and the doctor need to be told that beta-carotene is present in high amounts in that formula? Absolutely. And
well, especially because they've removed it from even, 13 years ago, 14 years ago, they removed it, or beyond that, from the ARED supplement.
So credibility is really important around this, and the science, I'd like to repeat it again, science that is made available that hasn't been modified or hasn't been changed. And I'd say the same about the AREDs. America, loves the AREDs, particularly retinal doctors. They'll put pressure on the wonderful optometrists that are trying to do the right thing, moving with science, and say, AREDs. AREDs isn't available anymore. The formulation that was used in the ARED study is not the formulation that's in the products that are being sold in America today. It's a different source, so is that the same? We don't know, because there's so much that can go wrong. We spoke today about technologies, but with formulations, there is so much that can go wrong in terms of stability, the presence of other undisclosed, undeclared carotenoids. There's all of these issues that the doctor and the patient needs to be informed about. They deserve this,
No, I agree, and I think that actually plows into my very final question when we talk about certification and standards. Is, they mentioned an NSF certification, which I didn't know what that was, and how does an NSF certification in one supplement compared to like supplement certified, and the analysis that supplement certified does?
Yeah, thank you. And for disclosure, I say that I have no ownership of supplements or technologies. I absolutely don't. I do have Supplement Certified is a campus company from this university. Okay, so I created that company with a scientist downstairs, Alfonso, and now many other people. So that's a disclosure there. But to answer your question, the difference between Supplement Certified and some of these NSF or whatever are used is Supplement Certified does analytical quantification. So we're taking the supplement, we're cracking it open, we're checking exactly what's in there. You're producing a chromatogram, which is actually, I have it here. I'll show you. This is actually ironically on the skin, or maybe I'll send it to you so you get it better. But you can see that's like a chromatogram. So we can see everything that's present there in the skin. So that's why I know when we do measurements exactly what's going on. So it's an exact science. So we will Supplement Certified will take any product from any company, from anywhere in the world, and if they are committed to quality, they go on a journey with that formula, whereby when it is produced, it is provided, and this is an ISO process, so there's no particular scientist needed. It goes into a process. It gets analysed at at the beginning of its shelf life and throughout its shelf life. And it will confirm back to that company if the particular compounds that they're claiming, carotenoids in this case, or omega we do too, is present at the right amounts and if it's staying stable over the shelf life.
In my my recollection of what we have discussed before on Supplement Certified, which was probably a couple of years ago now, maybe a year ago, is that you don't disclose outside of that company. They can come in and analyze it, and you're not going to go and publicly. Is that right? You don't actually disclose. You will tell the company what they want to know, but you don't come out and say, well, this supplement we found this or this. Is that right?
That's correct. And if they don't, so if a company comes to me or to the laboratory, rather, to the organization, says they want to become a member, that means that they're committed to having their products tested by Supplement Certified. We will analyze their products, and if they have a problem, we'll tell them they have a problem and they don't keep their certification, because we wouldn't be allowed to. So they have to be passing this. If they want other products analyzed, which we've had done, numerous companies have asked us to analyze other products, we do that, but we don't. We're independent. We're not, there is no bias. It is an absolute process. The process is available, and it's more important than ever. I'll tell you one thing. You probably noticed I'm a bit emotional today.
No.
I feel I'm answering the same question.
You're passionate about what you do. I love it.
But let me tell you why, particularly today. I've just come back from a trip with my mum and my dad, and we took them to Spain on a vacation with the kids. And unfortunately, my mum had a really bad episode on vacation, and we had to call the paramedics to the hotel we were staying in. Okay, so we didn't know if she was having a stroke or what was going on. So obviously, I went straight to first aid, and I said to my mum was still able to kind of communicate poorly with me, and my dad too. And I said, I need to know all your medications right now. That's the first question. As any good first aid, that's where you start. Okay, once she had a pulse, I wanted to make sure what medications she had or what she had taken. And she took out, as part of her medications, her carotenoid, her macular supplements, right? And that says to me how important my mum, who I could have lost 2 days ago, that's how important that is to her. And that's where this started for me. When I started doing a PhD, I didn't know about macular degeneration or that much, or about carotenoid. I went on 25 years studying this. This is my whole life. That's why it means the world to me. Mm-hmm. That's why it's important that we're just honest about the conversation. And if you don't have science to present yourself, please don't try and discredit science that is bona fide, that is evidence-based, that has gone on that journey. And that's my protection. And it's a protection of you, Chris, and eye doctors, because I really do care about your industry. I think you're wonderful people.
Yeah,
I think
clearly.
You're moving into a place that I call Health 3.0. If we're going to get ready for aging, if we're going to help people be happier and have vision for longer, there's ways we can do that. And there's room for companies to coexist and behave and just be honest. And the one thing I'll say to you, Chris, and any of your listeners or anyone that's ever been, everything I say is said with a scientific evidence base, based on data that I have, based on data that I'll make available. And if I see someone challenge that inappropriately for self-gain, which is exactly what I believe, that's what I'm calling out, that's what I believe happened, it needs to be stopped, it needs to be corrected, and it needs not to be allowed. When I travel to America, we do their COPE application, like I'm sure you've had to do for different lectures you've done, and the whole process that you go through there and so on. That's great. Maybe one of the dangers we have is these kind of pay-to-play platforms, and I'm sure the organization that received money to host that discussion believed that the information that was going to be presented on that was going to be accurate and informing, because that has to be a duty of care of any journal, whether it's peer-reviewed or not even, I don't care. We all have a responsibility to be honest. And, the last point I'll make is, if you've heard anything from my voice today, it's that we're really doing good in this industry now. Doctors are really leading the way. They're becoming brave. We've seen that it works when it's done right, and there's room for coexisting, but please just be honest. Please be honest. That's what I'm saying to And that's why I would have the conversation today if the doctor wants, tomorrow, whenever. I'm here to hold.
So you'd be willing to come back on just so I can make this public. If
100%.
I can get that previous presenter on, you'd be willing to come on with them and have an open conversation. And I will moderate it, obviously, but it would be respectful. Is that correct?
I don't know any other way.
Okay. Now, all right. So I think to your last point, and this will be my final request, because I'll be respectful of your time, and we've been able to maintain kind of all of our live listeners pretty at a steady level the whole time. So I want to be respectful of their time as well. I'm going to put something back on you, and maybe you can have one of your PhD candidates that's working for you, whatever. But you actually listed a lot of citations, and I would love it if on this post, on this LinkedIn thread, if you can kind of add a list of the citations that you have made, so people can evaluate what you've said and make sure that they don't have any other questions. And then obviously if anybody else that disagrees with it, they can post their citations and their interpretation of it, and we can further this conversation. So Professor John Nolan, thanks so much for coming on. I really appreciate it. It's helped me kind of work through this. I don't think, again, I told you I was when I heard that, I had to go back and rethink. This has helped me think through that, and I'm open to new ideas. So if there's anything we missed, anybody can come on and tell us what's going on. So appreciate it. Thanks for coming on, John.
It's a pleasure, and I'll give you one job if you don't mind. You've given me one.
Yeah.
I'll provide those.
Yeah, I'll take a job.
If you could look and see yourself if those big claims that challenge your own thought process, because your call to action was a reevaluation. Is there science to back up your reevaluation or your recalculation of the facts? So I put that back on you. My data and my literature, and that, it's not mine. It's like Paul Bernstein, Liz Johnson, all these people that have committed their life to this science. We need to represent all of that correctly. But so sure.
Yeah, I'm gonna dig in those further. I looked before, but I'll dig more and see. And if I find them, I'll post them as well.
Thank you. God bless.
All right.
Yeah.
Thanks a lot. Appreciate it. Thanks everybody for jumping on. Have a great one. We'll see you on the next